consider something maybe even a little bit more complicated, a system of several capacitors. So we're going to have a voltage source right here, and it's going to come up here, and we're going to have a capacitor there. It's going to go up here to two capacitors, and then that's going to be one capacitor right there. That comes out, but alongside all this is another capacitor right there. And then this all connects back to the voltage. So this is C1, C2, C3, C4, and C5. All right. And so I'm going to tell you that the V naught is going to be equal to 14.5 volts. C1 is going to be 21.0 microfarads. C2 is 40.0 microfarads. C3 is going to be 50.0 microfarads. C4 is 25.0 microfarads. And C5 is going to be 30.0 microfarads. And so I want to know what is the charge and voltage on every one of those capacitors. Okay. Now, what students will often do is they will often say that the voltage is all going to be, equal to 14.5 volts. That is absolutely entirely wrong. If you do that, it is wrong. Don't even expect partial credit, because I'm telling you right now that's wrong. Okay, so what you want to do is you look at the problem and say, okay, what would this be like if it was one capacitor, one equivalent capacitor? So let's work backwards there. Well, we look at what's in series and what's in parallel. Well, C2 and C3 are in series. So they act like one capacitor that's in parallel with C4. And then whatever that little tank thing up here is, that's in series with C1. And then those two along that top path make an equivalent capacitance that's in parallel with C5. So this is the method of what we call reduce and return. So right at the very top, we have C2 and C3, and they are in parallel, they're in series with each other. So that means the equivalent capacitance right there is going to be 1 over 40 microfarads plus 1 over 50 microfarads, and all that to -1. So that's going to be equal to 22.2 microfarads. And so now we have that C2, that right there. Okay, and that was in parallel with C4. So what we have is 22.2 microfarads in parallel with 25 microfarads. Well, you know that parallel capacitors just add. So that means that little tank sort of thing there is going to be 47.2 microfarads. So now our circuit looks a little bit simpler. Now we have C1 up here. All that stuff collectively acts like 47.2 microfarads. And then we have C5 right there. Okay. Well, these two are in series. So we have 21. So that means up there at the top, then that's going to be, so we can actually replace this and say C5, and then we can call this like up at the top here C top, okay, and all that is like this, okay. And so C top is going to be 1 over C1, which is 21 microfarads, plus 1 over 47.2 microfarads, the -1. So all of that stuff turns out to be 14.5 microfarads. So that's going to be 14.5 microfarads. This right here is going to be 30 microfarads. So that means that the equivalent of this entire circuit here is going to be 30 microfarads and 14.5 microfarads. In series are in parallel of 44.4 microfarads. So the entire thing can be replaced like this, where this is 14.5 volts. So if we wanted to, we could find that the Q equals CV, so that would be the total charge on the entire thing. So the total charge on the entire thing would be 44.5 times 10 to the minus 6 farads times 14.5 volts. And so that would tell you that the total charge on everything, all of this together, 44.5 10 to the minus 6 times 14.5, that's going to be 6.45 times 10 to the minus 4 coulombs. Now, I did not ask for that, but it's useful to go ahead and do that because we can use that later. Okay, but what we have here is we have that equivalent top capacitor, and we have C5 right here. Okay. And so we know that both of these have that voltage on it because this is all equipotential, this is all equipotential here. So that means voltage top equals voltage 5, which equals the V0, that's 14.5 volts. So that means we could real quickly find that Q5 is going to be C5 times V5, so that's going to be equal to, so that's real quickly going to be 30 microfarads times 14.5 volts. So Q5 quickly comes out to be 4.35 times 10 to the minus 4 coulombs. So now we have that. Okay, what about the C at the top? C top, or the Q at the top, is going to be the C top times the voltage. Okay, so that's going to be, we said that at the top up there, that was going to be equivalent of 14.5 microfarads. So that'll be 14.5 microfarads times 14.5 volts. Okay, so that comes out to be equal to 2.10 times 10 to the minus 4 coulombs. Now, the charge at the top plus the charge on C5 should be the total charge. So does Q5 plus Q top equal the total charge? And the answer is yes, it does. So that means this is a check. We've done something right. Okay, so now at the top up there, that Q top, that the C top, we know that really that was C1 and that other equivalent, the tank sort of thing, and the tank sort of thing there was 47.2 microfarads. So that means that we know the Q top, so both of these have that same Q top. So that means that Q1 is going to be equal to that 2.1 times 10 to the minus 4 coulombs. That means that for the little tank thing over there, that's going to be the same as well, which means we can find V1. The voltage is going to be Q1 over C1, so that'd be 2.1 times 10 to the minus 4 coulombs divided by C1, which is 21 times 10 to the minus 6 farads. So V1 comes out to be equal to 10 volts. What about V2? Well, there's two ways of figuring this out. One would be to take that Q divided by the other. The other is to say, oh, wait, we know that that this voltage plus that voltage equals 14.5. So that means that V2, this voltage right there, I guess that's not V2, but that's V right, okay, that voltage right there has got to be 4.5 volts, okay. Well, that thing there, that capacitor on the right, that's the capacitance of that little tank. Remember, that little tank was really that, where that was C4 and this was C2 and C3. So we know that the voltage on there is 4.5 volts. So that means that V4 is 4.5 volts. And so that means we can quickly find Q4 equals C4 times V4. And if you multiply that out, because we now know what V4 is, we know what C4 is. So Q4 turns out to be 1.12 times 10 to the minus 4 coulombs. Okay, what about up here? Okay, well, we could figure that out too. And we could say that this we call this, like at the top up here, we could say that Q top equals C top times that voltage, okay? And so we already figured out that at the top up there, that's 22 microfarads, okay? And we say this is 4.5 volts. So that means this is 9.99 times 10 to the minus 5th coulombs. Now, if we did it right, this charge plus this charge equals the total charge that is the same as C1, because this charge here had to split between those two. So what happens if we add the two together? If we add the two together, then yes, within rounding error, it is the same. Okay, because we already said that Q1 is 2.1 times 10 to the minus 4 coulombs. If we add Q top plus Q4, we get 2.12 times 10 to the minus 4 coulombs. That's close enough within rounding error. Okay, so at the top up there, where we have C2 and C3, then we know that that is equivalent to a 22.2 microfarad capacitor. Okay, and we know that the charge on that, we just calculated that is 9.99 times 10 to the minus 4, or 10 to the minus 5 coulombs. So that's going to be the same charge on each one of those. Okay, because it's got in order to go through here, it's the same charge going in one side, going out the other side, so they both have the same charge. So that means that Q2 equals Q3 equals 9.99 times 10 to the minus 5th coulombs. Okay, so now we can find the voltages. So V2 is going to be Q2 over C2, and V3 is Q3 over C3. Well, you know what the Q's and the C's are. So that would be 9.99 times 10 to the minus 5th coulombs over C2, which is 40 times 10 to the minus 6 farads. That comes out to be 2.5 volts. If you divide the other one, that's going to be 2 volts. Now, we know that this voltage plus that voltage, V2 plus V3, has to be the total voltage there, which is 4.5 volts. 2.5 volts plus 2 volts is in fact 4.5 volts. So that means that in the end we have got each of those. Okay, 10 volts, 2.5 volts, 2 volts, 4.5 volts, and 14.5 volts. And we have all the charges. Okay, this is 2.1 times 10 to the minus 4th coulombs. This is 9.99 times 10 to the minus 5th coulombs. So is this. Okay, and then down here we have 1.12 times 10 to the minus 4 coulombs and 4.35 times 10 to the minus 4 coulombs.